In this video, we're going to talk about one-to-one functions. And so to start talking about one-to-one functions, first I want to discuss or review what a function is. A function is a relationship in which each x, let me erase that, each x is paired with only one y value. So that's what a function is. Every value of x is paired with only one y. So in other words, you're not going to have 4 mapped with 3 and then 4 also mapped with the y value of 2. You're just going to have 4 mapped with one y value. So now a one-to-one function actually is a function that works in the opposite direction as well, where every y value is paired with only one x value. So to illustrate this, let's look at the graph in example 1. The first graph A. This is a quadratic function, and I know that it's a quadratic function because it's got that smile shape. And if I look at this, and if I draw random lines through the graph that are vertical, it passes the vertical line test so that I know that this is definitely a function. And if I scan that graph, I notice that every value of x, it only has one value of y. However, it is not a one-to-one function because each y value isn't necessarily matched with only one x value. If I look at y equals 4, if I come across here, there are 2 different values of x, 3 and -5. Okay, so for the y value of 4, there are 2 different x values, so this is not one-to-one. Now, sometimes you'll see one-to-one function written notation like this. That also means one-to-one. So if it passes the vertical line test, then we know for sure it's a function, in which case this does. It passes the vertical line test. However, to check to see if it's a one-to-one function, then you're looking to see if it passes the horizontal line test as well. And if you notice, if I pass through and make horizontal lines randomly through this quadratic function, it fails the horizontal line test. It passes through more than one point just about everywhere. So graph A is not one-to-one. It is a function, but it's not the special function that's one-to-one, where it passes the vertical and the horizontal line test. Now, if I look at this graph here in part B, it passes the vertical line test and it passes the horizontal line test, which means for every value of x is only one y, and it works in the reverse that every value of y is only matched with one x. So in graph B, this is definitely a one-to-one function. And again, sometimes it's written like this. Now, the reason why it's important to have one-to-one functions is because if you have a graph that is not one-to-one, or any kind of function that's not one-to-one, when we go to find the inverse of that function and we switch the x's and the y's, then that might give us more than one x for each y. Or I think I said that backwards. It will give me more than one y for each x. So remember, because the inverse is when you switch those x's and the y's. So if you're starting and you have more than one x for each y, and you switch your x's and your y's, then you're going to have more than one y for each x. And if that happens, then that inverse is no longer going to be a function. Okay, now we learned how to observe if a function is one-to-one by looking at the graph, right? If it passes the vertical and the horizontal line test, then it's a function that is one-to-one. Now we want to look at ordered pairs. If it's in table form, how do we tell if it's one-to-one? Well, we want to make sure that there are no repeats. We don't want two different values of x going to the same y, or more than two different y's mapping with the same x. And if you look, in this example here, everything is unique. I have -3 only mapped with -8. I have -2 only mapped with -10. And vice versa. If I look at that in reverse, where I look to see what's mapped with y, that -8 is only mapped with 3, I don't have any repeats there. However, so this is one-to-one. However, if I look at the second example, this is not one-to-one. Because if I look, -3 is mapped with -8 and 4 is mapped with -8. So I have two different values of x that are mapped with the same value of y. And then I also have a couple of repeats here where 0 is mapped with 4 and 1 is mapped with 4. So this is a function, but not a one-to-one function. Okay, now looking at equations to determine if something is one-to-one, you can actually just graph it on your calculator, or if you know what the basic shape of the graph looks like, that's really helpful too. Like in part A, I know that that's the absolute value of x plus 4. I know that that has a V shape when I graph it. So if I know that it has a V shape and I start doing the horizontal line test on it, I know it's going to fail. So this is not one-to-one, part A. In part B, I can either graph it on my calculator, or if I know the shape, I know that a squared function, a quadratic function, has a smile or a frown shape. And I know if I start doing the horizontal line test on that, again, it's going to fail because I know what that basic shape looks like. This is not a one-to-one function as well. When I look at part C, I know that the graph of square root of 4x has this basic shape. It looks like an arch. It starts at 0, 0, and it has an arch. Now, if I do a horizontal line test on this, it's going to pass. So this would definitely be a one-to-one function. In part D, I know that this is a line. And if I graph a line, and I do the horizontal line test on it, it's going to pass. So this is one-to-one. If you don't know what the shapes of those graphs are off the top of your head, put them in on your calculator and graph them and look at it. Then use your graphing calculator as a tool to help you.